Okay, let's get started. So I've got our LED circuit that we designed hooked up on the bench and power supply set for 12 volts. Got a 470 ohm resistor inserted. In case you haven't seen it before, this is the way resistors, through-hole resistors often come. They come in a reel with paper on each end, and these are rolled up in a reel. These are yellow, violet, brown, and gold. And the yellow, violet, and brown indicate 470 ohms, and the gold indicates that it's accurate to 5%. So let's turn the power on to the circuit, and look at that. It lights up like it's supposed to. It's not too bright. We're not burning anything out. We've got the power supply set to 12 volts. If I look across the circuit, I've got 11.9963, which power supply is pretty good because at two significant digits, that's 12.0. And then let's take a look and see how much of that voltage is across the resistor versus how much is across the diode. So if we look across the resistor, we've got 8.76. And if we look across the diode, we've got 3.23. So it turns out that Kirchhoff's voltage law works, right? The voltage across the resistor plus the voltage across the LED is equal to the voltage across the circuit. Now let's look at the current. And so to do that, we're going to take our meter, and to measure current, the meter goes in series with the circuit. So we're going to switch this over into the current input, and we're going to switch the meter into DC current mode, and it turns out to be 18.93 milliamps, which is exactly what we designed the circuit to be. Right? We went from a 440 ohm resistor, which would have provided 20 milliamps. We increased it to the next standard resistor size or value, which was 470 ohms. And we predicted it would be right around 18 point something percent. Keep in mind, of course, that these are 5% resistors. So we can actually check that. That's something else that we can look at. Let's power the circuit off. Let's switch our meter into 2-wire ohms mode. Go back into the connector here. And let's pull that resistor and measure its actual value. So I'm going to hook these up. And there we go. So we had said it's a 470 ohm resistor as marked, and it's actually 464. So, 0.464 kiloohms is 464 ohms. So that's certainly within the 5% tolerance of the resistor. So this is part 2 of our resistor circuits video. And I've got our voltage divider circuit set up on the bench. I've got a 1K resistor in parallel with a 1 megohm resistor, and I didn't have 0.1% resistors. These are 1%, and that's going to be plenty close enough for what we're doing here. And then I didn't have a 515 ohm resistor to put in series, but I do have my trusty Heathkit Decade resistance box, which lets me dial up any value I want between 1 ohm and 999,999 ohms. So I've got that set for 515 ohms. So the power supply is set for 5 volts. I've got the meter set across the entire circuit. Let's turn the power supply on and see what we get. So 5.0003 volts. I think that's plenty close enough to 5 volts for what we're doing here. So we're going to leave that there. Now let's take a look across the load itself, right? So we'll look across the 1 megohm resistor. See what we get here. and 3.2998. I'll call that 3.3. So I'd say we've designed the circuit perfectly, and the bench proves it out. So we can see that on the meter. Let's just take a quick look at the current. And so I'm going to change the circuit around. To measure current, we always put the meter in series with the circuit. And so I've just done that, and we'll switch to the current input and switch the mode to current. And it's we said we had 3.3 volts across a 1K resistor, which should result in 3.3 milliamps. And that's pretty much what we're seeing here. There's probably some slight difference in the resistor values that's causing little differences, but that's close enough. That would work in our design. So we designed it, we built it, it works exactly like we expected it to. Couldn't ask for better than that.